This is Unit 2, Segments, Lines, and Angles. Preview Video 2.4, Part 1, Segments and Informal Proofs. Right here, we are doing Preview Video 2.4, Part 1. Make sure you get a location, date, time, as well as a parental sign-off that they know that you did this on your own. We're going to be talking about something called segment proofs. Now, do not be intimidated by this word proof. All it means, a proof, is simply an explanation. It's just an explanation. When we talk about proving something, we just mean explain something. Okay? So don't be overwhelmed. We're going to be talking about critical reasoning and explanation. Now, in research, you have to be able to explain your steps and answer the question, why is this particular avenue of research, or why are your results positive or negative? In the legal realm, we use something called precedent. Why is some activity or another activity legal versus illegal? When you're writing an essay, you have to usually include what's called justification in English essays, and that would be the why. In English, you're told to support your thesis with information or references to the book. So this step why is what we call a proof. We already did a version of this using algebra. Let's solve this problem on the left together. Now you ask yourself, between this step and this step, what was the why? What was the reason that's allowed? And that would be the distributive property. Okay, now watch what we do next. What we did was what you commonly see as collect-like terms. We added these numbers on one side, and then we added these numbers on the other side. Adding or subtracting on one side of the equal sign, we didn't cross the equal sign, that's addition, subtraction of real numbers. From here to here, we added 15 to both sides, so that would be the addition-subtraction property. Here we subtracted across the equal sign, so that's addition, subtraction property. Last but not least, we divided by 14, so that's multiplication, division property. So all of these steps answer the question, how did you get the answer? This last step is, what is the answer? On the right, we address the why is this mathematically reasonable? How, what, why? Now to do the next step, believe it or not, being able to do these hidden pictures is actually quite important. I want you to pause the video and then give yourself 1 minute to spot as many differences as you can from top to bottom. Pause the video. Alrighty, students, take a look. See if you spotted all the ones I did, and if you happen to have spot one that I missed, please let me know. So that part of your brain that asks, what is the difference? What is different? What is different? That's the part of your brain that we need online right now. That's why we did this. Now, in your reference booklet, this is where you're going to go to these 2 pages. In your reference booklet, find these 2 pages. So you are now in your reference booklet. On the top here, all segments also follow, segment distances follow these algebraic properties. Distributive property, addition property, cross multiplication property, multiplication division property, subtraction property, transitive property, substitution. In addition to those algebraic properties, segments can be symmetric. Which means the distance A to B is the same as the distance B to A. Segments can be reflexive. Reflexive is where a segment is shared by 2 distinct shapes, exactly shared. So this really helps if you color code this. So I have 2 segments here. I'm going to call this RS segment, and I'm going to call this AB segment. So on the left, the RS segment is shared by that triangle and that triangle. So we would write the reflexive segment like this. We would say that segment RS is congruent to RS. Whoa, yeah. Tough stuff, right, folks? On the right-hand side, be very careful. We have overlapping. Okay, do you see that blue triangle? Why don't you physically trace that blue triangle? Now, physically trace that red triangle. Watch again. Trace the blue. Trace the red. Do you see how those triangles exactly share AB? That would also be reflexive. So we would write AB is congruent to AB. Transitive. Transitive says this. Let's say I have two segments. PQ is congruent to QR. Let's write that right here. PQ is congruent to the segment QR. Let's say it's also true that QR is congruent to RS. Notice what segment is repeated. We transfer the congruency from PQ to RS. Therefore, we could say that segment PQ is congruent to RS by the transitive property. We transfer congruency at the overlapping segment QR. Segments can be added, which means the distance P to Q plus the distance Q to R equals the distance P to R. Smaller segments add up to larger segments. That's called segment addition. We call that segment addition. Still in your reference booklet, segments can have a midpoint. So if I say P and R and I claim Q's the midpoint, notice the hatch marks. That's my sound effect for hatch marks. This is true. PQ, the segment, must therefore be congruent to QR if Q is a midpoint. So welcome to your first, what's called geometric proof. Remember, a geometric proof is just an explanation. We're going to walk through these 4 steps: given, implied, freebies, talk through. Given, implied, freebies, talk through. Very, very important. Never skip these steps. They spell out the acronym GIFT. Given, implied, freebies, talk through. Given, implied, freebies, talk through. Note this icon, no naked diagrams. It means you put your given information on the diagram. There's 3 steps to all proofs. Those 3 steps are, we're just going to put them in the margin. What, how, why. What, how, and why. So let's look at our given information. Given says read the given aloud and carefully mark on the diagram. I'm going to be using colors. I recommend that you follow me with the colors. It'll make it a lot easier. I'm going to use green, blue, and red. If you can possibly get those colors handy, pause the video and get them. It would be very helpful. All right, we are starting in this diagram that our distance A to D and CE are equal distance. So I go like this. I'm going to use brackets. I'm going to color code them. The distance A to D and CE are congruent. So bracket, hatch mark, hatch mark. You're also told that BD and DE are the same distance. So BD and DE are the same distance. We're trying to prove, remember prove just means explain. How do you know in this circumstance that the distance AB and DC or CD are congruent? I'm going to put a little question mark there. All right, so that we're done with our given. Implied and freebies. Implied are things you know to be true because of the given. Freebies are things that are always true, even if it's not marked. Careful. Any one of these segment properties are always true. So let me give you an example. Okay, what's implied by this is, it's really simple. We know this distance, D to E, plus the distance C to D equals the distance C to E. In other words, red plus green equals blue. That's implied. That's called segment addition. We also know that this is true. BD plus BA or AB, same thing, equals AD. Both of these are true statements. Do I need them? You don't know, but it is a true statement, so you mark it down. So I want you to just pause for a second and ask yourself this. If the longer blue segments are equal and the shorter green segments are equal, how do you know the red are equal? Take about 10 seconds and talk yourself through that. Go. At some point, you should have said the word subtract or take away. So this is how you're explaining how do you know this is a true statement. Why is this true? Okay, I'm going to walk you through it very, very carefully. I'm going to color code it with you. Take a look here. AD. Physically trace A to D. Guess what? That's the blue. Let's box it. Blue. Equals A to B. Which is the red. Plus B to D. Look, I'm tracing every single time. So the blue equals red plus green. Now it asks here, why is this a true statement? And it's a true statement because, check, segments can be added. Little segments add up to bigger segments. So the reason here is segment addition. Let's do the next one. C to E. Trace it. Trace, trace, trace. That's blue. Equals CD plus DE. That's green. That's little segments add up to big segments. That's called segment addition. Why is that true? We're answering the question, why? Now look at step 3 very, very carefully. AD and CE are exactly the same. Why is that true? It is a given piece of information. Now I'm going to draw in close because this is the what happened with this picture comes in. Look really carefully. Look super carefully. Pretend this is a puzzle. Look at step 4. Look at steps 1, 2, and 3. I'm going to give you 20 seconds of quiet, and I want you to ask yourself this question. Steps 1, 2, and 3 did what to get you step 4? I'll give you 20 seconds of quiet. See if you can't kind of ask yourself, what happened in steps 1, 2, and 3 that gave you 4? Think it through. 20 seconds of silence. Okay, let's see if you saw this very, very, very carefully. Do you see AD? Do you see AD? We swapped out AD and we put in its place this. Do you see CE? CE? Notice I'm circling. We swapped out CE and we put in its place this. So we used step 3. We swapped out AD and put that in. We swapped out CE and we put that in. That is called substitution. And we used steps 1, 2, and 3 to substitute. Look very carefully at step 5 and ask yourself, where do we get that true information? Do you see it? That's true because it's given. Now, look at step 4 and look at step 6. What is the difference? Spot the difference. It's like a game. What is the difference between 4 and 6? I'll give you 10 seconds. See if you can't spot the difference. Box it. You see, that's the same. That's the same. That's the same. Look at what we did. BD, DE. We swapped out BD and put in DE. And we did that because we said in step 5 that they are equal or equivalent. Therefore, you can swap them out. Therefore, you swap them out. Let me color code this for you. Okay? AB is the red. DE is the green. CD is red. And DE is also green. Remember, we're trying to get the reds to be by themselves. So what is step 5? We substituted. And what did we substitute? We used steps 4 and 5 to substitute into 6. Now look very carefully. Do you notice you now have the exact same thing on either side? That means you can subtract the same segment from either side. Notice what we did. We subtracted the same thing from both sides. That is the subtraction property. Congratulations, you just finished your first geometric proof. We have mathematically proven that those red pieces are, A, B, and C, D, are mathematically the same distance. That is called a geometric proof.